Hi everyone. So I'm recording this video to show how to install the stack that I proposed within this post. Um, I don't think I need to give much of an introduction because probably you're going to be watching this only if you've seen this at least once. And nevertheless, I'm recording this for everyone, so I might also go over some steps which are obvious. Yeah, bear with me. Uh, I'll start from scratch. I'm going to install this on a Raspberry Pi 4 because that was the last request I got. It also works on the Raspberry Pi 5 for those like me who kind of came to the Raspberry Pi world very recently. So I already got the 5 first, and then I realized most things still require the 4. And final bit of information, I'm going to use an SD card running Bookworm. So the way you get there is you just Google Raspbian OS Lite. In my case, I'm going to use the Lite version, so without a UI. You will find operating system images as the first result on Google. Scroll down to the Raspberry Pi OS 64-bit. And at the time of speaking, the latest version is 12 Bookworm. I downloaded this already. You will then need the Raspberry Pi imager to flash it on whichever boot drive you want to use. As I said, I'm going to use a SD card today. I strongly recommend using a USB drive instead because it's so much faster. As in, like the whole setup takes significantly less time when running on an SSD drive. So I'm going to choose Raspberry Pi 4 here, operating system. I'm going to use custom and just drag the one that I downloaded from a page I was in before. For storage, I think I need to plug it in again. I'm going to use the SD card. There's a few important steps that need to be taken now. So you want to edit the settings. You want to set a host name. I use the Raspberry Pi, which is, I think, the most standard host used on the Pi. You can do anything in here. This will only define where you then access the services from in your browser. You want to set a username and password. I used Pi, and then I chose a password. And you want to configure wireless LAN. So you want to point the Pi to your internet connection and provide the password for it. Um, One word about this, in order to run the stack, because some components run on MQTT and stuff like that, and in general, it's a Docker stack, so services need to communicate with one another. You will need to have a router. You don't necessarily need an internet connection, but it's better if you do, because then you can also connect to your Pi remotely via Cloudflare. It's something I will not cover in this video, but it's quite simple to do. And so if you have a running internet connection that your Pi can connect to at any time, it unlocks a lot of possibilities. You also want to enable SSH, so you click services and make sure this is ticked. And that's it. And then you hit save and you say, yes, would you like to apply OS customization settings? Do I want to erase the media? Yes. And this will take a while. I need to type in my password. It will take a while, so I will probably speed it up. Okay, the flashing is done. So I took the SD card and placed it into the Pi, connected everything. On the first boot, it will take a couple of minutes, especially if you're running on an SD card, for the Raspberry Pi to be accessible and reachable. You can check. I'm on a Mac, by the way, so everything I'm doing in my terminal is for Mac. Probably you can do similar things on Windows. I just don't know the commands exactly. So you can ping Raspberry Pi .local, which is the host that I chose within the settings a few minutes ago. And mine is already reachable. So because of that, I can SSH into it. So I can write SSH pi. That's the username I chose during setup at Raspberry Pi .local. I will have to confirm that I trust this and give my password, which I also chose during setup. All right, and I'm now in the Pi. So nothing so far is specific to the setup that I'm describing today. Of course, this is just how you generally flash OS on an SD card and SSH into the Pi for the first time. What I'm gonna do next is I'm going to go to the GitHub repo for what I call VanPi Docker stack. This is heavily, or let's say, I started this um, out of a project which is called IoT Stack. It's a very well maintained project, uh, currently owned by one of the people on YouTube, at least, who are uh, producing the most content about IoT and Raspberry Pis. Um, and yeah, I think it's a good basis where to start from. It's not really a dependency, but the install script within this project, as you will see in a minute, actually fetches this project and runs over the setup for it, just because that is a really nice installation script for Docker and Docker Compose. So one thing at a time, I will just go through the getting started guide. I will have to install Git first of all. So I go back to my terminal and just copy paste sudo apt install Git. Um, yes, I want to continue. I need to install Git just so that I can then clone the Git repository I'm now looking at on GitHub onto my Pi. So I will run git clone and then the URL of the repository itself, which will clone it into a directory which is labeled the same as the name of the repo, so VanPi Docker stack. I can then go in there and run install.sh. What is this doing? So first of all, this is going to take a while, again, mostly because I am on an SD card. It's not going to be instantly executing on an SSD drive, but it's going to be significantly faster. What is this doing? It's installing very few dependencies, so Python, Vim, which is a text editor for the terminal, for those who don't know, and DRenv, which is a very nice utility that allows you to define environment variables within each directory wherever you need them. So you have an envrc file, um, and you just write your environment variables in there, and those are loaded every time you access the directory. It's a really easy way to define environment variables. You'll see in a minute or two how that is used. And there's this block which I ported from the original install script. What it's doing is it's setting up the host system, so the Raspberry Pi itself, so that it can communicate with I2C and OneWire for things like temperature sensors. I'm not sure if this part is needed. It was under the same description within the original script, so I ported it over. I'm not sure what the reason for this was, and I haven't tried removing it and seeing whether everything works anyway as expected. I have a suspicion that it will, so maybe if you know about it, just let me know. Then it's running some Docker patches, which are actually coming from the IoT stack getting started guide. So right, so it's just a few things that need to happen so that Docker will work properly on the Raspberry Pi. Where was I? Here. And finally, the last thing it's doing is it's fetching the install script from IoT stack and running it. All this does, I think it's probably already running by now. Let's see. Yeah. So all this does is it installs Docker and Docker Compose. The script itself also does a few checks, so it won't install Docker and Docker Compose if they're already installed. It will also reboot the system after everything is done. So it can be that this is a bit of an overkill way of installing Docker and Docker Compose because I'm fetching the entire project. As I said, though, it's a really nicely maintained project, and I think, yeah, this is a really nice install script for Docker and Docker Compose. In the future, I might try to make this a bit more lightweight and yeah, simply install the two things that are needed and skip the IoT stack part. Let's see if it's true. Yeah, the system will reboot now. This was almost a minute ago, so it should be reachable again. Might have typed it wrong. Bear with me. All right, yes. So, okay, we now have two directories in here. We can actually remove IoT stack because we don't need it. The only purpose why it was installed was so that its dependencies, therefore Docker and Docker Compose, will be installed. So I will run rm-rf IoT stack and then cd into the directory of the VanPi Docker stack and keep on following the getting started. So I have to create a folder called volumes. I can get into that folder. And then I have to clone a bunch of repos which are dependencies to the stack. The order, of course, doesn't matter, but I will still describe what they are. So VanPi API Git, sorry, VanPi App API is the backend API for the UI, which pretty much glues everything uh, that needs to be glued within the project. So it's just a REST API. The VanPi React project is the UI itself. It's called VanPi React because the UI right now that I'm using is written in React. VanPi MQTT Hub, this is something new that I added over the weekend. I will probably edit the post that I left in the forum to describe a bit what it does. Basically, I wanted to add some sensors for tanks, and I want to use ultrasonic sensors over the ESP8266 or ESP32 chip, which allows to broadcast values that are read by the sensors to an MQTT topic. In order to not be constrained to a fixed amount of sensors that I can add, I realized that we need to have an MQTT hub. Otherwise, we will need to go into Node-RED and create one listener for each of the MQTT topics which each sensor is publishing to. I don't want to go into the full detail of this, but that's the reason why this is there. And then VanPi GPSD to MQTT, that's also something I reworked over the weekend. I was originally using the GPSD module for Node-RED in order to get GPS working, but that was not really optimal. So I figured it's easier or better, let's say, to again write something that just does that. So this is a small service that reads data from the GPS daemon, that is GPSD, and publishes those values to an MQTT topic so that they can be consumed by other services. All right. I need to go back to the root folder, and this is where I will set up DRAM. There is an envarc example file provided in the repo, and I just have to copy it there as .envarc, and then I can say vim.envarc in order to edit it. If you don't know how to use Vim, you type I to insert stuff, and then you just go with your cursor to where you want to write, and then you can just write as in any text editor. Encryption key is just a random string that will be used to encrypt attributes within the database if any of the attributes need to be encrypted. DB password is just the password that I want to set for the database. So it's a MariaDB database, which is based on MySQL. I can just type my DB password. Of course, if you're doing it for real, choose something else. And the same for DB root password. I'm not actually sure what the difference is, but clearly the database needs both. So I will just add another password for that. DB name default, you can leave it like that. You can leave all the values that are already set like that. Maybe going through them quickly. These are the identifiers for the USB devices that are currently supported. One is the GPSD dongle. The other one is the Zigbee dongle. If you have them, you will be able to set them up through the UI. I'll show you later. And they will be available within your system under this alias. So you can also swap them around different ports and the system will remember them. You don't need to change those two. It's just so that you know what they are. The VanPi API root URL, that's the core API. As you can see, this is a Node-RED installation. You'll see later what this is. VanPi API allow domains. This is where these are the domains at which the API should be reachable. And I added app.mydomain.com. Of course, this is the placeholder. You can set up a custom domain that you own. And if you have Cloudflare running on it, which is a different topic I will not cover here, but there's plenty of resources online about how to do it, then you will be able to access everything remotely, including the terminal. So you will be able to SSH into the Pi remotely through that tunnel, and you can set up everything from here. Enable authentication false. So that's probably something that will be removed later because I implemented some form of authentication so you can have a login for the app itself. But that's probably redundant with the Cloudflare tunnel because that already handles authentication. So you probably don't want to have both. Therefore, I will leave it empty. Then there's a couple of MQTT topics which are going to be used by the system. One is the hub topic for sensors, and one is the GPS D topic for GPS values. And as I said, this one I will leave empty. So this is all Cloudflare stuff, not gonna go through it today. That was maybe a bit too fast. How do you save stuff? You tap colon, like the colon symbol, and then W for write. And again, tap colon and Q for quit. Once you change, or whenever you change the VanPi files, you need to run drenv allow. That's just how drenv works, and this will reload the VanPi file and load the variables into your session. How does drenv work? It works within this directory because I created the VanPi file within the directory. So if I get out of the directory, drenv unloads. And if I get back into the directory, all those environment variables are set, which is nice because if you want to have a different project which needs different environment variables, you can create another folder in here and create another VanPi file, and then you will have these other environment variables loaded in there. So at this point, I think we're done, and we can run docker compose app -d. -d stands for demonize, so it's not going to attach to the process. This is going to bring up the entire stack. For those who are not familiar with Docker, again, I'm making this video for, I hope, a relatively broad audience. So maybe I'm saying things that are obvious, but feel free to skip ahead. What's happening right now is the different services that are defined within the docker compose.yaml file in the repository are being built Docker compose.yaml file looks like this. So there is a list of services, each of which is based on some Docker image or builds from a Docker file. This is the case, for example, here. Um, these services are then configured in a certain way. For example, Portainer, which is a UI for interacting with Docker containers and images, will run on port 9000. So this exposes the port 9000 to the host. Um, I think most or all of the services in here are set to restart unless they're stopped. So whenever the Raspberry Pi reboots for whatever reason, if the power goes out and then it goes back up, um, the services should restart on their own. You will not need to do this regularly or SSH into your Pi under normal circumstances. You can just expect things to work once things are set up. And then some volumes are provided. So this is how you persist data and into your Raspberry Pi in this case, or whichever storage you're using. And the container can be recreated, it can be changed, it can be upgraded, you can rewrite an entire service and not lose the data because the data is kept on the Pi itself. So of course, this is a whole topic in its own. I'm not going to go further into it, but what's happening now is this file is being read and the services are being built. All the images need to be pulled from the Docker Hub registry. So that's why it will take a while. Plus, again, on an SD card, yeah, the I/O is not that fast. So I can tell you from direct experience that running this on an SSD drive plugged through USB 3 in my case makes it so much faster. Enough talking. I will be just waiting for this to be done and then in the meantime speed up the recording. Maybe one more word about the services that are more custom, so to say. So as you can see, many of these services come straight out of an image. For example, the Node-RED official image. For the VanPi Core API, that's maybe the most interesting one. I had to use the Debian version of Node-RED, of the Node-RED image. So if you look up Node-RED Docker, you will find a repository. And that repository includes, oh, this is not that, it's this one. That repository includes some custom Docker files. One is for Debian. The official release or the default release of Node-RED on Docker uses Alpine Linux, which lacks a lot of dependencies that are needed for the core API to run. Therefore, Debian is a better choice. So I pretty much copy pasted this file into the VanPi Docker stack repo, and I changed just a couple of things. So this is still pointing to Node version 16 and Buster, whereas this one, the one I copied or I modified, is pointing to Node version 21 and Bookworm. A couple of things changed as well, and I had to add probably a couple of dependencies. I think those, for example, it's just some Python packages that are needed for things like reading out values from the BMS of your battery. Same thing here for having access to Bluetooth and things like that. So it's a really minor adaptation of the official Debian image for Node-RED. Okay, in the meantime, the build is done. You can ignore this error on your first build, especially if you didn't plug in any GPS device. I'll do it in a minute or so and show you how it works. But this is just saying that it cannot access the GPS USB device. That's because there is none. But the stack is now up and running. So what I can do is I can go to Raspberry Pi local dash, sorry, colon 9000, which is where Portainer um, is served. I need to choose a password for Portainer. Choose something that you will remember. And I just need to click Get Started. Here I have my local stack. It's already there. You can see there are 14 containers in total. Not all of them are running already. Namely, the GPS stuff is not running, for example. The MQTT hub is not running and the Zigbee is not running. I have to do some further steps in order to set everything up. So the first thing is I have to go into the VanPi core API installation, which is a Node-RED installation, and basically pull the VanPi core API project. So I'll do that now. I can access it through Raspberry Pi local colon 1880, and that is because within the Docker Compose file, if I look up VanPi core API, you see that the port 8080 of the container is being exposed as 1880. So I'm getting the welcome to Node-RED 3.1 page or like dialog. I can close that. This enables Node-RED projects, which is the way Node-RED deals with GitHub and version control. So when projects are enabled, you can pretty much either create a project or clone an existing one. That's what I'm going to do. And you can then make changes, push those changes to the repository, pull changes that come from others from the repository, and you can pretty much run updates like that and handle conflicts within Node-RED through a UI as opposed to having to copy paste things around. So here I have to give my Git account details. And then I want to clone the VanPi core API. I will clone it through SSH because that makes it easier to set up a key and add it to my repository so that I can push to it. For you, it doesn't matter. So you can also clone it through HTTPS. If you want to make changes to this repository, though, it does matter. So you can go in here and fork the repository and then clone your repository instead of mine and basically follow what I'm doing now. And then you will be able to push and pull changes and it will all work seamlessly. So I'm going to copy this URL, paste it here. The project name is already pre-filled. I don't have an SSH key right now because this is a fresh installation, so I have to add one. I will call this RPi4 demo VanPi core API and generate a key. Okay, this is a public key, so I don't need to blur it. You cannot do anything with it, but I can add it to my repository. So if I go to SSH and add a new SSH key, I will again call it RPi4 demo VanPi core API. Add it here. Need to add my password. All right, that's done. So I can close. I think this is a bug. So I'm now left with an empty page. So I have to refresh and just start the process again. But now I will have an SSH key as soon as I copy paste this URL in here. So it's the RPi demo VanPi Core API key that I just cloned, that I just created, so I can clone the project. All right, and I need to install some dependencies. These are the MCP 23017 chip. First, I'll do that. So I go here, manage palette, install, look this up, install it. Then I need to look for MySQL. And I think this is the package that I'm using, node country MySQL config. So I will install that one too. And then PyGPIOD as well. By the way, this one, I'm sure it will come in handy at some point, but for controlling the relays, I realized this is not needed. At least it doesn't look like it's needed to me. So in the original VanPi OS flows, you had both uh, actions that were targeting. Maybe I can open that so it's easier to follow what I'm saying. Yeah, you basically had relays 1 to 8, and each of them was targeting a different bit on the MCP 23017 chip, and also doing something with GPIO. I realized that this is not actually, at least like not noticeably doing anything. So for the time being, I deactivated those. That's again something where I would like to maybe have some input because I'm not sure what the background for it is. Okay, so then everything is running now with regards to the core API. That's good. I will have to do the same with the automation API, which is running on port 1881. It's the same process, so I'll be quicker about it. The repository is different, obviously, so it's VanPi automation API. I will have to create a separate SSH key for this one. RPi for demo. VanPi automation. And again, add it to my SSH keys. Then again, copy this one, refresh the page, clone, and this should just work. It shouldn't require any further dependencies. This is a much smaller project at the time of speaking. Okay, at this point, I should be able, let's see why the app is not running, first of all. That's strange. Well, I will just start it. The core API is running. The React frontend is running. The automation API is running. The database is running. So the database was created automatically. There was no need for anything to be set up manually, other than setting the passwords as environment variables, of course. Right. Let's check whether the API also started. Yeah, it did. So maybe something is wrong in the Docker file and this is not restarting automatically. I'm not sure. I will check that. But anyway, you can start it manually. And at this point, let's also check the React logs. There is a lot of warnings in the React project. The React project is really dirty at the moment, as in like it will need to be cleaned up, and it's really just a proof of concept at this point in time. But it's running, so I can access it at Raspberry Pi Local 3000 because that's the port I'm exposing for that service. And you can see it's running there. I can go to settings. That will be the first thing I do. And I right now everything is empty, right? So there's no battery, there's no water tank, there's no relay, Wi-Fi relay, mode switches, action switches, switch groups, nothing. Um, this is also something I added over the weekend. So in order to handle things like restarting the GPS container when the GPS settings are changed, without having to go into Portainer yourself, you need to provide a Portainer access token, and you just have to do it once. It will be very nice that this happens automatically, and I think it is possible to make it happen automatically. I just didn't find a quick way yesterday when doing it, and so I just, for the time being, kept it manual. So you need to go in here again, like I clicked on admin my account and hit access token, and here we will call it, I don't know, VanPi. What is that? VanPi Docker stack, whatever. Let's add that. This is obviously something that you will want to keep relatively secret. I mean, no one will be able to do anything about your Portainer unless they have access to your network, which at which point probably you're screwed anyway. But nevertheless, this is the kind of stuff that you don't want to publish around, or you certainly don't want to put it into a repository or anything like that. All right, now I already have too many tabs open, so let me just close them up because I don't need them, except maybe Portainer. And in here, I can just paste the value that I got. GPS devices, they're not connected right now, so we'll just save this and go to connect the GPS and ZigBee MQTT devices. I'll put up a picture so you can see how it looks on my Pi. I'm using a USB hub, which is also something that is made possible by the fact that USB devices are remembered by their IDs instead of by the port they're connected to. So since I connected the hub now, you can see that there's a bit more here in the menu. I had to refresh the page for this stuff to come in, of course. The GPS device is this one. It's one of those mouse looking like USB GPS thingies. The ZigBee device is called ZigBee, so it's easier to find. I will also open my network tab so we can see what's happening behind the hood. A lot of what's happening right now really is mostly happening in the backend. So as I said before, the front end is currently the least developed part of the whole stack. You can see that this is taking a while, and the reason why it's taking a while is that it is automatically starting the services behind GPS and ZigBee. So if I actually go to Portainer and go to containers, I should see that these, if everything is working, should be starting as soon as these requests are through. Maybe I can also open the core API to see if everything is working there as expected. It's taking a bit longer than usual. Let me try that again with this open so that I can see if there is any error. Oh, so this was saved. That's something. Maybe let me add a debug here. I don't need a debug. Probably it will just throw an error if anything is wrong. Oh, okay. I'm not sure why this is happening because this should be executing at start and it should be creating those views. So let me see. restart flows, and clear here and save. Okay, looks better. At least I didn't get the error. Yeah, not sure why this happened, so I will look into it. But in theory, maybe I should change this one to live somewhere else. Maybe this could be actually migrations. That would be a good idea. Right. In theory, this should work out of the box, and you can see that the GPSD service was started automatically by the app. Same for Zigbee, and same for the GPSD to MQTT service. I'm not sure why this one is also not running. I would say maybe some misconfiguration in the Docker file. All of this is work in progress, so I'll take notes and improve that. Right, so after starting the last one thing manually, everything is running. And in here I can start adding things. So I took some notes. My battery, for example, MAC address is this one. I have a 280 ampere hours. I'll just call it like that. Lithium battery, at the moment, all I am supporting is, as in like all I added support for is what I have, and that is a JVD BMS. So I can save it. Water tanks. I will add a picture of the sensor I built, and if you're interested into how that's done, I also did it through a repository and a blog post that I found. It's a ultrasonic distance sensor. So it basically measures when plugged into a tank, and it's also waterproof. It measures the distance between the top of the tank and the fluid that is in it. So I can just add one as an example. I can call it fresh water. Again, everything that is supported now is what I have. So that's MQTT connection. I set up my sensor. That's a completely different topic. I'm not going to go into it now, but it's going to publish because I set it up that way onto the water sensor test values topic. And then I can say already what kind of tank it is. So let's assume it's a rectangular box, and it's maybe 100 centimeters tall, which is a very tall tank. 50 centimeters wide, that's massive, and 30 centimeters long. It's very weird shape. And I can also set how far away the sensor will be to the full tank, for example, if it's installed in the lid. And all right, I can save it. This is again something that is taking a bit because it's basically adding this device to the unless something went wrong. No, it went through to the MQTT hub. So I will not have to go in here and create a listener for this MQTT topic. Imagine I will have maybe 5 tanks in my build, 4, 3, however many. I don't want to have to go to Node-RED and add an MQTT in Node for each of those. I just want to be able to control them from here. So what the MQTT hub does is it listens to all of these topics. In this case, it's only water tanks, but in the future, it might be more types of sensors that publish on MQTT. And it republishes what is received onto a common topic, enriching that with some metadata, for example, saying this message comes from the freshwater tank. This way, it's possible to build logic that just goes, that works for an indefinite amount of sensors. You don't have to restrict it to a fixed amount. Just checking that I have enough time. Relays. Okay, let's add a few relays. Let's assume, or like, let's pretend the water pump oh, is running on position one. The icon will be something like water. All the icons here are material UI icons. So you can look up material icons and you can just use anything that you find in here. It has to be snake cased. In case it's made of multiple words, you see how, maybe with some other example. And then let's say that relay position 2 is, not sure, I don't know, some shower maintenance valve, something like that. I think build was the icon for something that makes sense here. Okay, let's just keep those two. Okay, now I save the relays and I can therefore control them from the control panel. You see later, I can add Wi-Fi relays. Again, I only have Tasmota, and therefore that's what I implemented so far. The MQTT topic for the Tasmota Wi-Fi relay module that I set up, I called it for now Tasmota test. It has 4 relays, so I can still define, say, one as relay position, and then this one I will call it, I don't know, the inverter. Let me look up an icon for electricity. That would be nice. So electric bolt. Electric bolt. You can see that it pops up here. All right, I will save that one as the only one. Mode switches, this is something that I think I described already in the post. I will add a winter mode. I think I called it winter travel actually in the post, so I will stick to it. The icon will be something like snow. AC unit. AC unit. Save it. Action switches are something that I think is interesting. So I don't like the name, first of all. If you have a better suggestion, please go ahead. It's basically switches that group other switches. So you can decide that, for example, you will have a shower mode. This might not make any sense, but just for the sake of the example, you will need the water pump to be on when you're taking a shower. You will need the maintenance valve to be off. And then you want maybe a shower maintenance switch. Again, here I would maybe use the usual tool, which does the opposite incidentally. So it wants the pump to be off, and it wants the maintenance valve, whatever that is, to be on. Okay, so those will now be available in my control panel, as you can see, and they will work in a way that pretty much enforces a state as long as something is selected. And then switch groups is where I can organize my control panel. So I can say maybe I have a home group where I want to have, I don't know, the shower stuff, and the inverter, and maybe the winter travel. I don't have to add to organize all of the switches, so you can also keep some of the switches empty. Sorry, hidden. For example, I don't want to expose this one probably because it's part of a set of actions that is being taken by this one. So it makes little sense to have it as an individual button. So I will call the second group maintenance, give it the usual build icon, and then drag my shower maintenance action switch, which I defined there in here, save. So now to recap, I have added some general settings. I have added one battery, I could add more. I have added one water tank sensor, I could add more. some relays, mode switches. I grouped some relays into so-called action switches, and I organized them into groups. So now things should start show up. So if I go to control panel, I will see that maybe I make this a little bit smaller. That I have the switches that I configured, organized the way I configured them. So I have a home tab, which shows shower, inverter, and winter trouble, and the maintenance tab, which shows shower maintenance. I can turn on the shower, and this will turn on two relays because I configure the water pump and this valve. Oh no, sorry, the valve will be off. So it will turn on one relay in this case. It could turn on more relays if I configure to do so. Also, it doesn't have to be only relays or only Wi-Fi relays. It can be a combination of both. Doesn't matter. I can turn on the inverter. Not sure if you can hear the ticks coming from the relay board. But yeah, just trust me, things here are working. I can turn on the winter travel mode that activates no relay. What it does is it broadcasts this to the to the automation API, which lives on Raspberry Pi Local 1881. So I described already how this works elsewhere in the blog post that I left, in the forum post that I left. But winter travel, for example, I set it up so that it will do something when the temperature goes below a certain level, in this case 2 degrees, and it will do something else when the temperature goes above 6. This is how it's controlled. So it's just a UI piece that sets a mode to on or off, and then this is being taken over by this backend, which then can automate things based on the state of the dashboard. So I'll turn this off. One thing that is interesting, maybe, pretend I'm taking a shower. As you remember, we set up another action for shower maintenance that is pretty much doing the opposite of what the shower is doing. So it's turning the pump off and it's turning that valve for maintenance on, whatever that means. Now, since I'm taking a shower now, if I click on this one, you will see that this doesn't turn on. At the moment, I'm not displaying any error message in the front end, but if you look at what the request returned, it says there are conflicting actors found, and that is the action switch one. So because the shower is currently turned on, this one refuses to turn itself on. And then when I'm done doing a shower, I can turn this off. And then finally, I can do some maintenance on it, and this will work. There's not much more to show in the front end. I think maybe, so this is actually static. The battery information is coming in. I'm only displaying the state of charge, but you can see more information here. Actually, my battery, I think, lost some 30 ampere hours because of some bad cell, probably, or I will have to rebalance them. So I called it 280, but in fact, it's 250 right now. And that's fully charged. And yeah, there is all the values for the different cells and so on. Yeah, not much more to show here. Maybe I will go then to the backend because there is more stuff in there. So you can see, for example, that hopefully we have some GPS connection. So if I just inject this and run this GPS get info node, which obviously is also available to the API. I just didn't implement anything in the front end that uses it yet. I get GPS information of where I am right now. Temperature sensor should be working because it's connected. And yeah, the temperature is 18.69 degrees right now. This is the the native, let's call it, temperature sensor for the VanPi board. So the one I got with the board itself. I plugged it in and it's working. Yeah, we don't need to test the Tasmota. Maybe we can test the water tank sensor. So let me clear this up and see if, of course, it's not turned on. So I'm powering the sensor, put a picture of it again, still through my laptop. So let me just plug it in. And sometimes it takes obviously a few seconds until data starts coming in. Okay, but you see I plugged it in and already some other debug node is telling me that the water test sensor is now online, which is good. And let's see if it's already pushing data. Yeah, it is. So um, right now I have it some 24 centimeters from my laptop, which is I think the next thing in its way. And therefore it's saying there is 24 centimeters between the top of the tank, which is where it should be, and the surface of the water. The total volume is being calculated because of the dimensions that I plugged in earlier. And yeah, this is also something that I just hard coded in previously, and it calculates the remaining volume in the tank, which is 121 liters, given the dimensions of the tank. Yeah, I will say that's it for this day's demo. I hope this was useful, and of course, this is undergoing. I'm spending a lot of free time on it right now, so I would extend it as much as I can. If anyone has any question, feedback, idea, whatever, just shoot it my way. Thank you. Bye bye.